Let's discuss the question number 18 from test 4, and this is from engineering mechanics EM. Okay, so a block is given, 50 kg mass block is given on a rough surface, and a force P is applied at 20 degrees, which meets at a direction which meets 20 degrees with the base. Now the friction coefficient, the static friction coefficient is given μs, and the kinetic friction coefficient is given as μ3, and the force value is P is equal to 150 newtons. So what is asked is how much is the magnitude of the friction force acting on the block. Okay, so for this, let me just draw the free body diagram of this. So you have the weight mg, and this P I can basically resolve. Okay, so this will try to move forward, so friction will be like this, and there will be a normal force N. So let me just resolve the P. So you will have the 150 cos 20, and you have the 150 sin 20, and the weight mg, the frictional force F, and the normal N. Okay, and let me just denote the coordinate axis x and y. Okay, so now as the block will be at rest and it will not move vertically, it will not move normally to the ground, so sigma Fy will be 0 for sure. This is sure shot. So let me just write down that. So N minus, so taking the forces which are positive upwards as positive, so N minus mg, and N is upwards, and this 150 sin 20 is another force. Okay, so now let's substitute the values. M as 50, G as gravitational acceleration 9.81 plus 150 sin 20, and this by using calculator I get 439.196 newtons. Okay, so this is the normal reaction which is exerted by the ground on the body, exerted by the rough surface on the body. So now let's see what happens in the Fx direction. Now Fx direction I don't know, because see, the surface can support a maximum friction, and that maximum friction Fmax, the maximum friction which a surface can support, maximum friction that a surface can support. So that Fmax is basically my the μs, the static friction, into the normal reaction which is N. So μs is basically 0.4 into normal reaction is 439.196. So this comes out to be 175.678. So this is the maximum friction that a surface can support. Okay, now let's see what is the requirement. Okay, so what I'll do is I'll just find out sigma Fx, and sigma Fx in this case comes out to be, so let's take all the forces which are in the positive, x as positive, on the towards right as positive and towards left as negative. So it will be 150 cos 20. This is the only force that is acting towards right, and F is the frictional force. Now I don't know whether this F is whether it crosses the maximum friction or it is less than the maximum friction. So what I'll do is I'll just find out 150 cos 20, and 150 cos 20 value comes out to be 141. So now for this to be in equilibrium, I mean the block to be in equilibrium, now my friction force comes out to be 141 newtons, and that is acceptable because this is still less than the maximum frictional force. Okay, so remember this diagram. The frictional force, when the load is applied, this is the frictional force, and the load is applied, load is increased from 0 until the load, till the friction available is maximum, and then once thereon whatever load you keep, the frictional force will be, so this is my limiting friction, which, or the maximum friction which a surface can support, and beyond that it is constant, and the value is mu k into mg. That is beyond the thing. So this is for a general body. So what I mean to say is the friction required for the rod to be in equilibrium is 141 newtons, and the maximum friction that is available before it starts sliding is 175. So the block will be in equilibrium and the friction is 141 newtons. So the answer is A. Thank you.